In this video, we are going to demonstrate some of the options available in the spherical plotting module. To begin with, we're going to load the dipole.dat file from the advanced data directory. This is an actual dipole that Diamond Engineering had fabricated and measured. After the data has been loaded, we will want to recall the gain data into the display register. All of the plotting routines operate from the display registers. Next, we're going to go ahead and invoke this spherical plotting module. The main data plotting usage options are to use linear, to use the power, or to use the log. In this case, we're going to use the power display. We're going to go ahead and plot the frequency response at 2.3 GHz. This dipole was actually measured L over as. A normal dipole pattern would be symmetrical at about the azimuth axis. Along with the mapping options are the abilities to overlay ideal dipoles and isotropic spheres. In this case, we're going to overlay an ideal dipole with a gain multiplier of 1 and a grid resolution of 5 degrees. To do this, we invoke the dipole and replot. What we are presented with is an ideal dipole superimposed over our actual measured data. Along with this option, we can also add isospheres. The maximum gain for the plot appears in the dB value window. In this case, it's 4.3 dB. Now we're going to add an isosphere with 2.3 dB gain. So I'm adding an isosphere and a half-wave dipole. Now what we're presented with is a graphical representation of the three antennas, the measured data, an ideal isosphere, and an ideal half-wave dipole. It is also possible to employ mapping to an ideal sphere of unity radius. In this case, I'm going to go ahead and check Map to Sphere and replot. Now what we have is an ideal sphere with the intensity pattern mapped onto it. And this concludes our overview of just a few of the basic options available in the spherical plotting module. Thank you for watching, and we hope this video has been helpful and informative.